Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about serializing and deserializing a binary tree. The explanation is completely based on the assumption you already have some basic coding knowledge. If you are not good at basic coding, please watch our website learningmonkey.in, take the course placement training for service-based companies, then come for the competitive coding. Coming to today's example, so given a binary tree, our task is to serialize and deserialize the binary tree. Serialization means convert a binary tree into array. Deserializing means convert whatever you converted, take that array and convert it into binary tree. That is what deserializing means. And you have to maintain, the structure of the tree should be maintained. That is how you need to convert and reconvert. Coming to example, input 1, 2, 3, 4. This is the binary tree. If you serialize, you have to get the output like this 1, 2, 3, 4. Similarly, if you convert this into deserialize, you have to get back your image, the binary tree back. So the logic is very simple, and you need to maintain a time complexity of order of n and space complexity of order of n. It's very important. Otherwise, you can go with the heap representation. In our basic coding, we already discussed how to store a binary search tree in an array. So when we discussed the heap, min heap, max heap, we used that array representation to store the binary tree. We can go with that, but it is not going to take order of n space. It is going to take 2 power h space, height of the binary tree. So that's why here it is bit important to understand how to serialize and deserialize. Coming to the logic, take a preorder traversal. Here we are taking preorder traversal. What's preorder traversal means? Display, then move to left, then right. So if you take this binary tree, 1, display it, then move left. 2, display it, then move left. 3, display it, then move left. Nothing. Completed, then move right. If the left completed, then move right to the second node. If left subtree completed, then move to the right to the first node. That is how preorder traversal works. Here we are taking the code for the preorder traversals, which we discussed in our basic coding. F of root node, display left, call the left node and call the right node. So this is what the order for preorder traversal. But what we have to do here, whenever you want to display, instead of displaying, place it in an add to a list. If you add to an array, that is what you are going to output. It's very simple if you understand preorder traversals and inorder traversals. See here, whenever, see the first node, find f of root 1. Instead of display, add to the list 1. Then call f of root tends to left, means it is going to call 2. Display means add to list. 2 is added to the list, call left. 3 is added to the list and call left. Whenever it is none, insert it as n. Otherwise you go with -1. You can go with any number, n or -1. So whenever it call left, if it is none, insert it as n. Then go right, n, then go right to 2, n. This is how this function calling executes. 2, n. Then we go to right, which is 4. Then we go to left to this node 4, which is none. Then we go to right to the 4, which is none. All the tree is over. This is how we are going to convert. So deserialization, exactly do the same, exactly do the opposite. Take the array one by one. You run the code exactly the way it is running in a preorder traversal. So now coming to the deserialization, take the input this array f of root. See, in the array, pop the elements one by one. Pop the elements means pop the first elements one by one. From the list, take the first elements one by one. And if the element is n means none. Otherwise, if you place it as -1, if it is -1, you have to return none. Otherwise, create a node and return that node. Exactly, our function calling should run exactly the way it is running in pre-ordered traversal. Let's take a look at it. So f of root, if n, return none, otherwise create a node and return. See, whenever this function call f of root, pop the first element. What's the first element? It is 1, so it is not n. Go to otherwise create a node of val. Whatever the value we pop it from the list, we are taking it as val, and we are creating a node, and that node address is placed in a root. Now calling the left side. Root dot left is equal to, again call the function root dot left is equal to this root dot left. Next node is in the pre-ordered traversal. The next element will be exactly left of 1. So that's why it is calling exactly same as a pre-ordered traversal. Now it is going to the next function. It is the next function. This function left is equal to f of a. F of a is going to take 2. It is going to create a node and again call f of a. Root tends to left is equal to f of a. It is going to call 3. Again left. Root tends to root dot left is equal to f of a. Again, and it shows n. It is going to return none. So this is how it is going to create one node, second node, third node left, which is n. It is going to place none here in the left. Now call this function root dot right is equal to f of a, which is going to take next n and place it here as n. This is exactly working as pre-ordered traversal. Last, return root. So this root function is given as to the input to the next node 2. It is going to place it in the left of root. That is how it is going to work. This is how we go with the serialization and deserializing the binary tree. Coming to the coding part, we are going to show you the coding part, but our suggestion is you try to solve it on your own. You can copy it, and the code is available in our website. You can copy it and you can use it. The best practice is write the code on your own. Hope you understand the logic. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.